When you're playing a game of rock, paper, scissors, there are two events in the game. The first one would be player one's move, and the second event would be player two moves. Those are the two events that would be occurring. In rock, paper, scissors, there are three different options. Player one could get rock, paper, and scissors. And it doesn't matter if player one chooses rock, paper, or scissors because none of these choices are being used up. Player two could also choose rock, paper, or scissors. Because the choices are not being used up, this makes the events independent as they do not affect each other. So I'm going to be making a tree diagram just like I did for the previous problems. There are, of course, other ways to solve, but I think it's a great idea to become familiar with how to make a tree diagram. So if player one gets rock, player two could get rock, paper, or scissors. If player one chooses paper, player two can choose rock, paper, or scissors. I'm going in the same order, rock, paper, scissors, just so it's easier to organize my data. And if player one chooses scissors, player two can choose rock, paper, or scissors. And then I need to tally up my results. So I can see that rock and rock are one of the possibilities. If this happens, the game is a tie. If I have rock and paper, I know that player two is the winner. If I have rock and scissors, player one wins. Tallying up for the paper going first. So if I have paper and rock, it would be player one is the winner. If I have paper and paper, those are the same, and so it is a tie. If I have paper and scissors, player two is the winner. I'm going to continue for the scissors. So scissors and rock would be player two is the winner. Scissors and paper, that would be player one, and scissors is a tie. The probability of player one winning, we can see that player one won a total of 3 times. Out of 9 total. So this is equivalent to 1/3 in simplest form. For player two winning, it is also 3 out of 9 total, which is simplified to be 1/3. And then the probability of a tie is also 3 out of 9, which gives us 1/3. Because the likelihood of all three events is all three outcomes is 1/3, that makes this game a fair game because all outcomes are 1/3. When you're playing rock, paper, scissors, you can see that it's a fair game and all the players are equally likely to win. If you're playing the game 12 times, we know that the probability of winning is going to be 1/3, and I can multiply that by 12. So when I'm multiplying fractions, they both need to be in proper fractions. Then I can just multiply straight across. 1 times 12 is 12, 3 times 1 is 3. This simplifies to be 4. So if 12 games are played, we would expect each person to win about 4 times. Now go ahead and try playing the game and see if your experimental probability matches up with the theoretical probability that we just calculated.